Hi everyone, I'm Charles, and I'm the developer of Rules, which is a trading cards game developed on StarkNet, on the mainnet. So I've been working on this project for the last 9 months, and I guess it's time to deliver what I've learned. So Rules user can buy packs of cards like that. They can buy a pack and open the pack and get random cards. This is the principle of the application. So the packs and the cards are on-chain tokens. They are ERC 1155 tokens. And then the cards have each card have a max supply of 1 token. So cards are basically NFTs. And packs have a max supply, which depends on the pack data. So it's like in a game where you can have some items, unique items, which are cards, and gold or stackable items like packs. But the main purpose of the application is to hold cards. So a card is defined by an artist, a scarcity. We have different scarcities like common, platinum, etc. Season. So this year, this is the season 1, and for the next year, we will have the season 2, then season 3, etc. And the serial number of the card. And for a pack, we have the number of cards per pack, and the card information. This is the information which describes what cards you can find in the pack. And so the max supply is the sum of the quantities of the different cards you can get, divided by the cards per pack. So this is how it works on chain. So you have, when you want to open a pack, you have the pack's opener manager, which is a StarkNet account, which we control. We have the private key in our backend. And so the pack's opener manager will trigger the pack's opener contract. And then the pack's opener contract will take the pack from the rule user wallet. When the pack is minted, the pack's opener contracts have, by default, the authorization to take a pack from any user wallet. But this authorization can be revoked if you want just to hold the pack and you don't want rules to have the authorization to take the pack from your wallet. So now that the pack's opener holds the pack, if the opening transaction is pushed, then the rules user can't front-run this transaction and cancel it by sending the pack to another address. And this is made to ensure that a pack opening can be cancelled when it's sent, when the transaction is pushed, to make sure that if a user finds the transaction and don't like what cards he will get in his pack, he can cancel it and try again to get new cards. So the next step is to trigger again the pack's opener. And this time the pack's opener will trigger the rules token contract, which will burn the pack and then mint 3 random cards to the rules user wallet. And then the rules user have his card and don't have his packs anymore. So this is the interesting part. This is how it works off-chain. So we have a bunch of scripts to orchestrate all of this logic. And this is what we had to develop to make the application work, even if the mainnet is not really ready to to deploy production apps. So we have 2 types of scripts. We have the block syncer, which will just get information from the accepted blocks and update the database. And we have some interactive scripts. So these scripts will interact with the blockchain and push transactions. So the first script is the account deployer. So when a user creates an account on Rules, he creates it in a Web 2 way, like with a username, email, password, etc. Then we have his account in the Rules database, and every minute the account deployer is executed, and then a wallet will be deployed for each user. And if if the account, the deployment fail, then the block syncer will not find it in the accepted blocks. And if the block syncer don't find it in the accepted blocks since an important amount of time, then the account deployer will check manually if the transaction hash has been rejected, and if so, it will try again. So now that the user have an account, we can mint his pack if he has purchased some packs. So the packs minter will just mint the pack. And once the pack minting is detected on the block by the block syncer in the accepted block, then the backend will randomly draw 3 cards and put it in the pool of cards, which will be used by the pack's opener later. So now we have the pack opening prepper. Each script is executed every minute, and we have a DLM algorithm. It's a distributed lock management to make sure that if the account deployer is executed, then there is no other instance of the account deployer that can be executed, and the same for the pack minter, etc. To make sure that we don't have corrected data and that we don't push the same transaction twice, etc. And we have also some some mechanism to make sure that that if the script fail or is timed out, then the data that is pushed to the database is reverted. And this is especially interesting for the block syncer, because let's say we have some modifications on the database detected in the accepted blocks, and then at the end of the block we have an issue in the script, and then the execution is cancelled. Then all the modification will be reverted, and the modification will be tried again in 1 minute. So we have now the pack's opening preparer. So this is the first step of the pack opening on chain, when the pack is taken from the root user wallet. So basically, it will just take the pack from the wallet. This is pretty simple. And once the pack is taken and this step is detected on the block syncer, one of the cards that we have drawn earlier in the pack's minter step will be associated to this pack's opening and will be used by the pack's opener in the last step. So the pack's opener will just take this pack, create the metadata on the EPFS network, and then mint the packs. So with this mechanism, we can mint many thousands of packs of packs and cards. So mint thousands of NFTs on the StarkNet mainnet, even if the mainnet is really in alpha phase. But with this mechanism, it works. And I think that's all. Yes, that's pretty all. We had some difficulties with the gas price that can vary, and we are, as you can see, every transaction comes from the pack's opener manager or our other accounts, like the pack minter or the airdrop minter, etc. that I'm not describing here. So we are paying for the gas for the users, but a pack only costs €9. So we have to make sure that it's still sustainable for us. So before sending each transaction, we are checking for the gas prices on the pending block. And if the gas price is acceptable, then we send the transaction. And if not, we are just waiting for the next pending block. And we are hoping that the gas price will be better. And yes, that's whole our orchestration mechanism, and it works pretty well for the moment. Yes, okay. So this is our website, rules.art, our GitHub, where almost everything is open source, where you can find more information about how we generate the keeper and how we store the private key to make sure that the account is non-custodial, but that the user will still be able to recover it if he loses his seed phrase. You have the Twitter, Instagram, and then the Discord of of the project.